I want to start by telling you what Jupyter actually is, and I like the citation from their own website that it's a free software for open standards and web services for interactive computing across all programming languages. So some kind of buzzwords which Ortrun already mentioned, like interactive computing, is very relevant for Jupyter, because you can be able to access programming languages and access computing kernels from your web browser, and very interactively by giving all the instructions to the computer step by step, and also trying to interact with it as you're able to correct things kind of on the fly. And it is also able to use different programming languages, not only one. Even if it's based on Python and was developed for Python, this is not the only thing you can run with this. If you've already heard of Jupyter, you may have already kind of a picture in your head what this is, and you may have not only heard of Jupyter, but of things like Jupyter Lab or Jupyter Notebook or Jupyter Hub, which are different sub-projects, and which I will try to sort a little for you, that you get a feeling which part actually is and what you really need to do it or use it on your own. So Jupyter Lab is what we're actually looking at the moment on my screen share. This is the next generation notebook interface. And inside of Jupyter Lab, you can, for example, edit Jupyter Notebooks, which is a file type you are actually writing all the code and all the comments in. And yeah, nevertheless, there is another thing which is also called Jupyter Notebook, which is the classic notebook interface. I will show you a screenshot in a minute that you can maybe spot the differences. But I would say when talking about Jupyter Notebooks, people talk about the file format nowadays, and yeah, about the content inside. So this is the thing you can share and which you could reuse, and the file thing we are storing our computations in, and which is evaluated by Jupyter and the kernels you apply. And yeah, the third thing, which may be already known or which you may have heard of, is the Jupyter Hub. And the Jupyter Hub brings the Jupyter universe to a multi-user perspective. Jupyter Lab and all the notebooks you can run on your local machine and just use it on your own. And with the Jupyter Hub, you get a multi-user version of everything. And you can log in and run your personal notebooks in an environment which is not necessarily located on your local machine, which you can then access also bigger compute machines with, and get access to computational resources on a very low level, low threshold to get access to this. Yeah, to show you how the project itself presents it, I'm now showing you the website of the Jupyter project. Here's again this quote which I read, and they're presenting basically the same three things as the first biggest parts of the project, which is Jupyter Lab, which is this user interface you can use, the next generation notebook interface. Yeah, the notebook just shows kind of the content of one file, so there's not so much left and right on this view, which we will explore in a few minutes. And yeah, most complicated addition, because it becomes more decentralized or centralized deployment, which you can use from anywhere, is the Jupyter Hub, where you can just plug any kind of authentication, have a central deployment, and which can be deployed on any kind of platform. Also modern things like Docker and Kubernetes, which are very likely to be better scalable than traditional deployments, come here very handy to be able to provide the computational resources in the required way. And very important for us as research data management people, or people interested in research data management, is the statement here on the right: code meets data. So you can run a Jupyter notebook on a Jupyter Hub, which may be located very close to your data. so you don't have to transfer all the data all the time to your local machine. You don't have to take care that your hard drive on your personal laptop or whatever you're using, your workstation, is large enough. You can just bring your code close to the data and run it there, in case you have a Jupyter Hub located somewhere nearby. Yeah, there are additional things, and they're also very proud of all the companies and universities who use anything from Jupyter and contribute. It is trying to use open standards and also develop open standards like the notebook format and also computing protocols and the kernels itself. And the whole Jupyter project comes with a, I think, very good and large documentation, which is linked here on the bottom left. And this is not only a documentation about the project itself, but also about all these side sub-projects I just mentioned, like the notebook and introduction where you should start. You can get all the additional information about all the details, and you could also get linked to the sub-projects, which some names now already familiar to you, like Jupyter Lab, Jupyter Notebook, and also Jupyter Hub. And in case you're working with notebooks, there are some handy small tools which you might get into contact with if you dive into a little deeper. For example, a notebook viewer comes in very handy if you want to present a notebook which you've already run to someone else without they having to rerun it because they don't have the data, for example. And all the kernels, which are not only Python, but for example, also R, Julia, or other things are available and partly community maintained. Yeah, with this, I want to step back into my notebook here, where I want to guide you through what we are wanting to discuss today. And the question may be, what is the advantage of joining the Jupyter ecosystem? Is it really helpful to have another tool which tries to help you programming? And I would say, especially if you're not an absolute expert, this can become very handy to have this kind of interactive graphical web interface. So all the stuff we are looking at today is just a website. So the interaction happens through a website, and you get direct feedback to your programming scripting. Not only in terms of output of results, but also the errors and warnings or graphics you generate can be directly seen in your web browser. And thus all skill levels can benefit from this low initial threshold to get started. It's also very easily to install, so a lot of documentation is available, and it shall be possible for kind of everyone who's able to install Python on its machine to also install Jupyter. And it can be used for learning, and especially for scripting or extension of existing scripts. And if you want to, you can also try to do really software development, even if there are more complicated integrated development environments outside. But you may want to use something flexible like Jupyter as well. Speaking of flexible, one big advantage of Jupyter is that you can run different programming languages, so-called kernels, and also different environments, so to say versions of different libraries you're using all in one place, and just switch kind of very spontaneously between all of these kernels and environments. And if you have the possibility to use a Jupyter Hub, you can run your code on usually big systems, which are much more powerful on your local machine and are typically harder to access without anything like Jupyter Hub. So you should be able to use a command line and something to get access to a compute cluster, speaking of high performance computing. But if you have a Jupyter Hub connected to it, it might be able to bypass also batch processing and things like this, that you could at least test out your scripts in the very first way, or your programs in the very first way, interactively, before going into batch processing mode, where you submit maybe thousands of jobs at the same time and have to wait weeks or months until they finish. So you're very flexible, and you can run whatever you want on huge systems, but you can also stick to the portable way and have it on your local machine and be totally independent. And this file format and this ecosystem can be very handy in different applications, and you're not required to stick at one of these examples. With this, I want to go into a live demo. This demo will be based on Python, and also try to introduce you to what the capabilities of such a Jupyter notebook is. So yeah, we are looking at a Jupyter notebook in this demo now, and you can provide different kind of content to a notebook. So what you saw so far was all about just documentation-like things, which you can write in Markdown, like I also did with this headline here, which is just headline in Markdown, then the content live demo in Python. And if I want to evaluate this thing, which is bluish now, which is in a cell, so-called cell in this Jupyter notebook, I have to press Shift-Enter and it gets rendered. Same goes for the next cell here, where I wrote the comment that you can either code in a cell, or it can be Markdown or just raw, and you can evaluate them using Shift-Enter. If I double-click it, we get into the edit mode, and if we press Shift-Enter, it gets rendered. The next cell here, I had put some Python, so to say, even if it's not very specific to Python. I think close to every programming language is able to calculate 1 plus 1. First line here is just a comment for you to guide you what I'm doing at the moment. So I'm doing simple math with an implicit output. So if I evaluate this cell where it's written 1 plus 1, it said that this is the first input I gave, which is evaluated, and the result of this first result is 2. So this is just an implicit output, because Jupyter Lab always gives you the output of the last command in your cell as a result of this cell. So 1 plus 1, everyone should be able to follow, is 2. If I'm doing this now using variables in Python, I can declare that A equals 1 and B equals 1 as well. And I'm defining a new variable C, which I'm defining as the addition of A and B. And now I'm not using an implicit output, but instead I'm putting a print statement here, which says print C. So it should be the value of C, which shall be printed here, which is also 2. So we put it 1 into A, 1 into B, add both up, save this into C, and printed this result. And got basically the same result, but this might be a little more sophisticated and can be reused way better. If we want to print multiple results, then we have to use the print command multiple times. For this one, I'm just trying to summarize what we did so far. So we did a declaration, we did A equals 1, B equals 1, then we did a calculation, A plus B equals, and now I'm giving here a variable C, and I'm also adding another print line, which is multiplying A and B, and then also printing the result. Everything in red here is just a string, so this will just be printed because I wrote it here. And the stuff here behind the comma is a variable which will then be read from the runtime kernel. So first paragraph here is just the text, declaration A equals 1, B equals 1, then calculation A plus B equals, and then the value of C, which we already had here above, is 2, and the value of A times B, which is 1 times 1, is still 1. So what you can see by now is that you are able to use results in a cell and variables in a cell which were defined and manipulated in cells which you defined above. So I'm reusing C and I'm reusing A and B and doing new calculus with them. And in combination with these numbers here in front, you can see what was done at which time. And here it becomes a little tricky because this Jupyter logic, or the flexibility, can also bring you in a position where you try to, or not try, where you confuse yourself, in terms that you could also define a value of a variable afterwards. Let's, for example, say stating now this C is now 3, and I'm typing Shift Enter. Now I have here input number 4, which is defining C equals to 3. And if I'm redoing or reevaluating the cell which the printing of the multiple results, I'm still writing what I gave as a string, declaration A equals 1, B equals 1, and the calculation is now showing A plus B equals 3, which is obviously not correct if you would assume that A is 1 and B is 1. But as I'm just giving here variable C, it's reading the variable from the memory, and I set it to 3 by now. So one really has to be careful what is one doing at which time. And if one writes a Jupyter notebook from top to bottom in a logical order, one shall also make sure that the evaluation order is the same. So one has to be careful not to fix some code at some point and not put it in the correct order. Because A times B is still correct in terms of this declaration, which I just wrote here. Yeah, just as a warning. So to fix it again, we could just provide here 2 and rerun also this cell. And it would be good again, or even rerun this cell, which we had as a second cell, which is now our 8th input, and rerun it again. And now it's still correct, or again correct. So that's just for the pure logic, how to run code in a Jupyter notebook on a very basic level, just adding some numbers. To show you a little more complex example, here based on Python, the first thing you should know, you don't have to write everything yourself, which you might be aware if you've already programmed in Python or any other programming language. You can always try to stand on the shoulder of others and try to import any packages or libraries from other people, and be very trustful and hope they made good work. And with this in Python, you can just import libraries which are installed on the system. In this case, I'm importing here 4 libraries for different purposes, which you will see in a minute why I need those. First one, NumPy, is just a numerical library to do some calculation. This pyplot thing from matplotlib is for plotting data. Matplotlib itself also for using, in this case, a color map. And CSV, you may know this file format, comma separated values, is to read in data from a file in this case. And if I'm evaluating this cell, all those packages are imported. Next thing here is to define some variables I will use later. So I'm defining a state variable, which I give the value 6, and I'm defining 2 variables, temp and year, which are both just an empty list for the moment. Well, I will fill in a second on the next cells. Then I downloaded some data. This is just a comment that you know where I downloaded the data, and saved this data to the folder. I have this Jupyter notebook in, and the next one is then loading and progressing the data. So the first line loads the data file, which I downloaded, and then using this CSV library, it reads it and goes through the data row by row and appends it to this, at the moment, empty lists. But after this loop has run through, those lists are filled with temperatures and year entries. And if I do so, this is now filled. And to check that this really worked out, I can, for example, just write year here and then have an implicit output, which just gives me the list with content now, or I could also write print year, and it writes it as a print command. And this makes it very interactive that I can just look into my variables without having to run through my notebook immediately. I can just make a new cell, have kind of a breakpoint, and evaluate what I'm working on and whether all the loops and variables are performing in a way I want them to. The next one is then for plotting and the processed data. So first line just creates a plot, which I can use. The next one is adding a bar plot with the year and the x-axis, and then the value 1. So it's just kind of a constant bar plot. Sounds not so interesting, but the interesting part comes about the coloring, which is a little more complicated. Yeah, I don't want to have any axes. I want to have a title, and I want to have it as a tight layout that it looks nice. And if you can look at the result, you see what I just mentioned. It's showing the years from left to right. All bars have the same height, and as the coloring, you can see these temperature stripes, global warming stripes, or in this case, the Hessian warming stripes. You may know from all the discussion about climate change and Scientists for Futures, which also provided this code example. With this, I want to draw your attention to some of the other features which Jupyter Lab and Jupyter Hub and maybe also Jupyter Notebook as a viewer have. So first of all, an autocomplete for code. So it also brings you some kind of modern environment where you can get some help in a very easy way. If I go back to this one here, and I want to say, okay, this looks nice, but I want to look into the data. I may want to plot it. And if I don't remember by heart how I have to do this, I maybe still know I have to do it via PLT. And the command was something like plot. Then I can just press, after I've typed something, the tab command, and gives me a possibility to choose from what is still available, and also reduces the availability. If I add some more, and if I'm fine with PLT plot, I can just press enter. I know this is a function which gets some arguments. And if I press the Shift tab at the same time, I get the signature of this function and the doc string. I can read through how to use this function just within Jupyter Lab. And for example, what I want to give is a very basic X and Y, just to see the variables. And this is also what is written here in the very front as a call signature. So X would be year, Y would be TMP. And if I evaluate this function, it doesn't work because it's not TMP, it's temp. And if I evaluate this one, I can see it in a different way. So both graphs showing kind of the same data, but in different representation. Okay, next thing. So I showed you autocomplete, I showed you documentation. I kind of skipped the error message, but I will create another one to show you the error messages which come inside. I, for example, will change the name of this file I want to read in and evaluate the cell. This file is not around in my folder. And if I try to read this in, I get an error message, and the error stays states file not found error. Error number 2, no such file or directory, and says me which file is not here. And I can directly see that this is my code and I have something wrong in this line. If I have more complex cells, I might want to also see which line number it is, and I can also add line numbers via the view option. I can show the line numbers in my cells to reevaluate, to see where I have to reevaluate my code and where I have to correct something. And as typically for Python, it tries to trace down the error to the moment where the error really races, and this is in this case that it tries to open the file somewhere in some library very deep into Python. We are not using, we are just interested where we did the error and may use the more in-depth information to find out what's really wrong. But yeah, to correct this one, we would just give txt again. No, this file is named txt, and reevaluate the cell, and it works again flawlessly. You can choose in Jupyter Lab out of a lot of visual options and also extensions. So I show you how to add line numbers, but if you go to the view here, you can, you can also show notifications, show hidden files, show the log console, collapse all your code and all your cells and everything, and also show into different contents like a file browser, which we will look into in a minute. And you can also try to have a different appearance of whatever you like. Yeah. Additionally, you can also have extensions with different contents. Yeah, I don't want to go into detail about extensions, but I can show you where you can find it. But first of all, I want to show you the basic functions, like, for example, the file browser. If you click on this file symbol, folder symbol here on the left, you can see a file browser here on the left sidebar, which is now stating that I'm not in my home directory, but in the subfolder HeFDI data talk. I could navigate through this folder structure now just by selecting the folder and going back in. Here I can see that I have 3 files in this folder, which is the file which is just opened, the HeFDI data talk IPynB, and the file we are always loading, regional averages tm-year.txt, and also some other example data CSV file. If you want to upload a small amount of data to Jupyter Lab on your machine, or even to Jupyter Hub, you can use this upload button here and could, for example, upload an image. And now you see here's now our 4th file. And if I double click this file, I can also view it inside of Jupyter Lab here and get an impression. The file viewer option is not available for all file formats, obviously, but for basic things like images or PDFs and also CSV data. So this can also be opened. Yeah, in this case, oops, I don't know. In this case, the CSV is not really comma separated. So you have to choose a delimiter, which is here, semicolon, and then it renders it also in a correct way. You could not only upload data, but you can also download data, which you just do by right-click your file, press the download button, and you get it back to your machine, wherever you want it. Maybe share it with colleagues or something like this. So this is very handy to transfer data between you and your Jupyter instance, whether Jupyter Lab or Jupyter Hub. Additionally, if you want to be more more into your system and want to maybe install something or use command line functions to perform operations on multiple files, you can also use the command line directly via Jupyter Hub. This can be done, for example, by clicking on the plus symbol here at the very top to add a new launcher, it's called, but we want to ignore the real launchers like Notebook and Console, but want to go to the terminal here on the left bottom. And with this, you get a new prompt where you can do anything which your system, where the Jupyter instance runs on, can work with. For example, I can list all the files in this folder, or I could, if I have to install something on my machine I want to use in Python, I can also state pip, which is the Python install or Python package manager install, and I would say NumPy now, which shall be already installed because we already used it. Yeah, and it's telling me that this requirement is already satisfied. I could, if I want to, I could upgrade my version of pip, which I don't want to at the moment, but my NumPy is already there, so I could use it. So this is a terminal. In case of Jupyter Hub, you run it as your user, so you're not administrator here. And this should maybe better be also done for local Jupyter Lab installations. Just run it as your user and not as a root user, super user. If you've installed something, you may need to restart your kernel. You have a lot of options about your kernel here at the kernel menu. You could restart it and clear the outputs of all your cells, or you could also restart it and run up to a selected or even all cells if you changed your input data, for example, or if you did major things. You could reconnect to your kernel if it got disconnected at some point, or you could just shut it down or interrupt it if it got stuck somewhere. And very important, you can also change your kernel. This can be either done here or here at the top right where it's written which kernel you're using at the moment. If you click there, you can just select what kind of kernel you want to use. In this case, I just installed one kernel. It's just a Python 3 on this Jupyter Hub. But yeah, if you would, for example, have also an R kernel here or Julia or another version of Python, you could select it from here and choose which kernel your notebook can use or uses. And yeah, as I already mentioned, this is Jupyter Lab, what we're looking at. This is the user interface. But yeah, you could also look from a different perspective. What's the difference to Jupyter Hub? Jupyter Hub mainly looks something like this. If you go to the web page, the link you get provided, which is first of all a login page. And if I log in here and accept the terms and conditions in this Jupyter Hub, which is the one of University of Marburg, I can select the job profile, which gives me three different configurations, starting from 4 GB of RAM with 4 CPU cores for basic usage, extensive evaluation with 16 CPU cores and 16 GB of RAM, and testing full scripts and computations with double the CPUs and RAM. And you would select start, and then it would start your job on the back end and provide you with the Jupyter Lab interface, which kind of looks actually identical to what I showed you on the other tab because it's sharing the same data at the moment. But yeah, obviously you could also log into different Jupyter Hubs. I wanted to show you also extensions. Extensions is this puzzle piece here. There you can search for extensions. Let's, for example, search for something related to Git. And then you get your search results here at the bottom and can check whether you want to have it or not and click on install, or click just on the name of this extension, and then you get information on this extension, usually via a GitHub link where this extension is then presented and what the requirements are and how you can use it. And with this, you can personalize your Jupyter Lab with all the needs you have. This button here is about your open tabs and your open kernels. So it shows you all the open tabs, and you can also close them from here, not only from here. It shows you the kernels I'm still using, and also shows you the terminals, because even if you close those tabs, the terminal remains alive and you can go back into it and see what we have already done there. And this one shows you the structure of your notebook. So as I'm using Markdown a lot. This is using all the Markdown headings to give this a structure inside of the notebook I've opened here. All right, so I hoped I could provide you an overview about the scope of all this Jupyter thing and all the sub-projects, and yeah, feel free to also do some research yourself on Jupyter.org, so find all the informations on the project there. This is more complete than I could do today, which was just an overview. And if you're interested now and you're asking yourself the question how to get started now using Jupyter, if you want to use it on your own, just use Jupyter Lab. You could install it on your machine. Probably you have to install Python before, then install Jupyter Lab on your machine. Start Jupyter Lab in the way the documentation tells you, and then you connect to it via your web browser, which will most probably be an URL stating something like either localhost or 127.0.0.1, and then some port for it to connect to it. And all of this is well documented on the webpage of the Jupyter Lab documentation, of the official project documentation under installation. And there are also a lot of tutorials on how to install it on the internet, most probably also videos you can directly follow. So I was not planning to include this into the talk today. If you want to use it as a service provided by someone else, you might be looking for Jupyter Hub. Maybe at your university or institution research facility, there is already a Jupyter instance which is hosted centrally. So yeah, either search your website or ask your local IT service. Maybe they have something like this. At University of Marburg, we are providing a Jupyter Hub for our researchers, which is based on our high-performance computing cluster Mark III. And it acts kind of as a graphical user interface to the cluster and enables an easy access to this kind of complex system, but yeah, enables the access for either results evaluation or testing and development, not only for experts, but also for users who are starting to get into the HPC topic and just want to do some number crunching on a little bigger machines. Additionally, we are offering a visualization service for notebook files, which is the NV viewer, which can be used to visualize your notebook files, and is also linked to our local repository data UMR, where you can upload Jupyter notebooks, which are rendered then there. Jupyter notebooks are rendered nowadays also in other types of programs. If you're using, for example, Visual Studio Code as a local integrated development environment, you can also render and also run Jupyter notebooks directly from there. And you could also upload Jupyter notebooks, for example, to GitLab, and they are rendered there as well. So they are not just stupid text files, but the web front end of GitLab also makes them look nice. And yeah, to add one information to this, so the notebook obviously stores everything I put in. So all the code I showed you today is stored in this notebook file. And on top of this, also all the results I produce by evaluating the code is stored in this notebook file. And this makes exchange and presentation via Jupyter notebooks also very interesting and relevant, because thus you can just upload it to somewhere and present this to other people, showing them the code directly connected to the results. And this can be very helpful to discuss and being on the same page when discussing algorithms and results. Yeah, and if you're interested in the service at University of Marburg, you can just visit jupyter.uni-marburg.de, and hopefully you can find all the information about the service there. And yeah, with this, I want to close my talk, and I'm open for discussion and questions. So feel free to unmute yourself and ask. Otto may have already got some questions in the chat already. Thank you very much.